Welcome again. This is Mr. Gee with another video that goes along with Algebra 1 class um, that I'm involved with at school. And what we're studying now is solving linear systems of equations by elimination. And so we spent time on doing two other worksheets, and hopefully people are getting a better idea of how to handle these type of problems. We're going to go ahead and work on problem number 2, and then we'll probably do problem number 4 and 5. Okay, so if you look at this first one, it's already in standard form. You can see the AX term is a negative 10x, the BY term is 6y, and the constant C is a negative 18. So I'm just going to go ahead and write that down just like it appears. And that equals a negative 18. Now on the other equation, it's all mixed up. You can see that we have an AX term here, and we have a Y term here, and a Y term here, and then we have a constant on each side. So what I've got to do is rearrange this. So I'm going to add 5y to each side. So that ends up giving me a 3y for here. We know that that one goes to 0, and the negative 4x will come forward. Now let's take a look at the negative 3 here, or the positive 3. I'm going to subtract 3 from each side. And so that's gone, and that's gone. So there's nothing left on the right-hand side, so it's actually going to be 0. So that's what happens there. So we went ahead and erased that up there to clean up our page a little bit. So now we want to get rid of the x term so we can find the y. So if I'll take 10 times 4, that equals 40x. And we know that we want the coefficients in front of the x term to be identical except for the sign. We want them to be off by a sign. And I usually like to get the top one negative and the bottom one positive. And the reason why we do that is if we add these two together, we get 0x, and what that means is the x term has gone away, and we're left with an equation that only has a y. And when it only has one variable, then we're able to solve for that variable. So that's the reason why we want this type of a situation there with our x term. Because if I eliminate the x, I'm able to find the y. So now we ask ourselves, what do I multiply a negative 10 by to get 40? Well, I multiply a negative 10 by 4. So there's the multiplier that I'm going to use there. Now I ask myself, what do I multiply a negative 4 by to get a positive 40? So that would be a negative 10. So those are the two factors that I'm going to use to rewrite these equations. So now let's go ahead. I'm going to make this one 4 times bigger all the way through. If I do it to the negative 10, I also have to do it to the 6y and the negative 18. So that'll be 24y. And then 4 times the negative 18 will be a negative 72. And now I do it to the 10. And that's a positive 3 there. So that will give me a positive 30y. And 0 times the negative 10 just stays at 0. Okay, let me bring down my other window here. I need some tools from here. Okay, so the next step is we add these two equations together, add up the columns. We know that this one is just going to be 0x, and negative 40 plus 40 is 0. And then 24 plus 30 is 54. Y. That's not right, is it? If I look right here, this should be a negative 30. A negative times 3, that should be a negative 30. So let me go ahead and change that. So you got to be really careful with your signs, people. So that should be a negative 30. So that will make that 14. So 14 makes it a negative 6. Y equals a negative 72. Alright, almost made a couple of mistakes here. So now we're going to take a negative 6y equals a negative 72. I divide each side by a negative 6, and so that tells me y equals 12. So there we solve for the y variable. Now we're going to solve for the x. Alright, now let's take a look at the y terms. Now to find x, I have to get rid of the y's. I know 16 times 3 is 18, and that's what I'm going to use. I know you could use 6, but I'm going to go ahead and use 18. So I'm going to take a negative 18 to the top and a positive 18 I want on the bottom. So again, we ask ourselves, now I've already used those two, so I'm going to cross those out so I don't try to use them again. So a negative 3 times 6 will give me that negative 18. So I'm going to times that by a negative 3. And then a positive 6 times 3 will give me a positive 18. So now we're going to distribute this negative 3 through the top equation and a positive 6 through the bottom equation. So a negative times a negative will make that a positive. 3 times 10 is 30x. And then a negative 3 times a negative 18, and negative times a negative is positive. And 3 times 18 is 54. Okay, now let's do the 6. 6 times, positive 6 times a negative 4 is a negative 24. X. And then 6 times 3 is 18 like we want. And then 6 times 0 is 0. Now we'll go ahead and add these equations together. Remember, we don't subtract here, we add everything. So 30x minus 24 is a positive 6x. The y terms go to 0, and I end up with 54. So we have 6x equals 54. So that means x equals, divide each side by 6, x equals a positive 9. So that's our solution to question number 2. So remember, when we write our ordered pair, the x comes first, so that ordered pair would be 9 and 12. Okay, I'm recording again. Okay, we're doing problem number 6 now, and if we look at the first one, it's already in standard form, so I don't need to do anything to it, so I'm just going to go ahead and write it down. And then if I look at equation number 2, I can see that I have a ax term over here and a by term over here. So I'm going to subtract the 2y. It's a positive 2y. I want it to go to 0, so I'm going to subtract it. And this is a positive 6y, so I'm going to subtract it as well. Or 6x, excuse me. Now that 6 is okay. So that's going to go away. That's going to go away. 4x minus 6x will give me a negative 2x. And then I have 5y minus 2y is 3y. And then I have a negative 6. Now when you look at this equation, what you'll notice is that we have identical equations. And remember from when we were solving these equations through graphing, when we have identical equations, it means we have infinite solutions. So if you encounter this on your homework or on a quiz, what you're going to do is tell me that it's infinite solutions, and then I want you to go ahead and finish solving the equation. So I know I want to keep this one a negative 2x. Change my pen there. And I want this to be a positive 2x. And now we're going to take this, and that first one, I just multiply it by 1. You don't have to do much to it. The second one I have to multiply by a negative 1. So I have 1 times a negative 2 is a negative 2x. 1 times 3y is 3y. And 1 times a negative 6 is a negative 6. Now for the next one, I have a negative times a negative makes me a positive. A negative times a positive makes a negative. So that'll be a negative 3y. And negative times a negative will be a positive, and that will be 6. Now look what happens when I add these two equations together. I get 0x plus 0y equals 0. So 0 equals 0. That's a true statement. So what that means is this shows me right here that I have infinite solutions, because it doesn't matter what I use for the x and for the y, one will equal the other no matter what y values that I use. So it means it's the same line. Okay, so you'll have this case sometimes. Now the next equation that I think we're going to do is probably number 7. So let me pause the video and we'll go ahead and pull up problem number 7. So if you look at these two problems, or these two equations, it looks like the first one is already in standard form. So all we need to do is write that one down. And then we've got a little bit of work to do here. This is almost in standard form, we can see here, but it's got the negative 29 with it. So we need to clear that just by adding a positive 29 to each side. And this new equation will be a negative 3x plus 5y equals 89. Okay, so I'm going to go ahead and erase this stuff right here. I no longer need that. So now let's go ahead and get started here. We're going to do this one in blue. So let's take a look at our x terms. We want to get them to vanish, to be eliminated, so we can find the y. So I know 4 times 3 is 12. So I want a 12x there and a 12x there. This first one I'm going to make negative. The second one I'm going to make positive. So to get a negative 12 from a negative 4, I'm going to times that equation by 3. And to get a positive 12 from a negative 3, I'll times that one by a negative 4. So now let's complete our multiplication. These are okay like they are. So 3 times 3 is 9y equals, looks like 213, and then a negative 4 times a negative 5, or positive 5 is negative 20y, and then 89 times a negative 4 looks like that's 356, and that should be negative. Okay, let's go ahead and add our two equations together. Remember, we always add our equations, we don't subtract them. Add a negative 12 and a positive 12, that gives me 0x. Positive 9, add a negative 20, gives me negative 11y. And 213, add a negative 356, gives me a negative 143. So a negative 11y equals a negative 143. I divide each side by a negative 11, and y equals a positive 13. Okay. All right, let's go on with this next one. So now I'm going to do this next one in black. We've used those already, so let's cross those off. So if I look at my y terms, I know 3 times y is 15. So I want 15y and 15y. One of them I will make negative, one will I'll make positive. So 3 times a negative 5 will give me the negative 15, and 5 times a positive 3 will give me the positive 15. So let's go ahead and multiply this through that first equation. So that will give me 20x equals a negative 355. And then 3 times a negative 3 will give me a negative 9x. And 89 times 3 will give me 267. I think that's right. Let me check it real quick. So 3 times 80 is 240. 3 times 9 is 27. Yeah, 267. Okay. So let's go ahead and let's add our equation together. see what happens. Okay, let's finish adding this together. I get 11x plus 0y. We'll add these two together and I get a negative 88. So my equation I need to solve now is 11x equals a negative 88. Divide each side by 11. So x equals a negative 8. So now I have a lot of students ask me, they'll come up and show me their answer and ask me if this is right. Well, you need to learn how to check your problems. And what you've got to realize about what we're doing is we're figuring ordered pairs. We're finding ordered pairs that are solutions to both equations. So this is an x, that's a y, so let's put them in for the x and y in one of these equations and we can check it. So I have a negative 4, my x is a negative 8, plus 3 times y is 13, and that's supposed to be equal to 71. So let's just evaluate this. Let's do the arithmetic here. Negative 4 times negative 8 is positive 32. 3 times 13 is 39. That's supposed to be equal to 71. So let's simplify this. 32 plus 39 is 71. 71 equals 71. So yes, it checks out as a solution. So this is the end of this video. I think we did problems 2, 6, and 7, something like that. So go ahead and if you'd like to leave a comment or subscribe to my webpage, that would be great. If you have any questions, leave a comment, what you don't understand, and maybe I can verify it or clarify it on another video. And thank you for tuning in, and have a good afternoon.